look on the cathode ray tube. There are some things that we need to know about the cathode ray tube, and those are the things that I'll point out to you now. What we have here is that we are going to have the ether be distributing heat to the cathode. So here we have the ether distributing heat to the cathode. Then we have the control grid to help to control the direction of the electrons that will be emitted. And from there we have here at this point, can you see this? We have one set of pair of what is called anodes. They are positive pole, they are positively charged anodes, and they are at very high potential. So they are at a very high positive charge or positive potential. And what happens is when the electrons are emitted, the electrons will be attracted to the positively charged anode, or the anode at the positive potential. And so what happens is that this will cause the electron to have an acceleration to the anode. Again, we have a second set, a pair of anodes, which further accelerates the electrons to a very high speed. And once the electrons are accelerated to a very high speed, it will strike the graphite coating on the screen and cause a scintillation. Now, what we want to point out further is that we have focusing coils. We have one set of focusing coils in the cathode ray oscilloscope. We're not going to talk too much about that today. And we also have deflecting plates. We have done previous classes with deflecting plates, and so you have seen in a much simpler case how the deflecting plates work. We're not going to go into all of that for this class. We're going to just deal with the electron being emitted. Alright, recall with me the name for the at cathode emitting electrons. When a metal emits electrons, the process is called thermoionic emission. Alright, so the ether is supplying heat to the cathode, to the at cathode, and as you can see here, an electron is emitted by the at cathode. That electron, once you have introduced the anode here at a very high positive potential will cause an acceleration of the emitted electron from the cathode towards the positive anode. We further introduce another pair of anodes that will help to further cause the electrons to be accelerated to very high speed. And these electrons, they are moving at very, very high speed. And what will happen now is that when the electron strikes the graphite at very high speed, what happens? It gives a glow. So you will see a light on your screen. It's the same principle that is used in the television screen. Once it strikes the screen, the graphite in the screen, you will see it gives a light. And of course, this is just one single spot that the electron hits right there. One other thing that we need to point out, that the cathode ray tube, that it's also known also as the vacuum tube. In some cases, it's called a vacuum tube. What it means is that we have a gas in this tube at very low pressure. And somebody might want to know, why is this gas at very low pressure? Well, we understand that the electron is very light and very small. So therefore, if we add a gas in this that was at a higher pressure, what will happen is that the electrons, being very light electrons, when they hit against the atoms in that gas, they would have been deflected by the atoms of that gas. And therefore what is happening therefore is that once if the electrons are being deflected by the gas in the tube, the electrons will not strike the precise location on the screen that we want. And therefore we cannot control the effects on the screen to display the pictures that we want on the screen. So to ensure that we have precise pictures, we have to ensure that the electron strike the screen at precision. And therefore the gas is at a very low pressure in the tube and therefore will not cause any deflection of the very light electron. And the electron will hit the screen at the particular point that we want. Now I want you to go to your syllabus. That's your O-level syllabus, and you can see physics syllabus page 19, which talks about this principle. I want you to pay attention to that, and we will continue to discuss the cathode ray tube as we go along. Thank you very much.